Welcome to Ganita Samayaha, an interactive learning space. Children, as I proceed with the teaching, whenever I pose in questions, please answer them. This will help you in the learning process. Also, please don't forget to have the writing materials with you whenever you watch these videos. And after watching the videos, please don't forget to subscribe, like and share these videos. In today's video, we are understanding about real numbers and it is part 2. I hope you all have not missed out watching part 1, children. In case you have missed it out, please go back, watch part 1 and then come back to part 2. This will ensure continuity of learning. And the link to part 1 is given in the description box below, children. So let us get started. Children, in the last class, I had given in a few assignments so that you would all work it out on your own. I am sure all of you are ready with it and very eagerly waiting for discussion. So let us discuss the same now, children. So the first question was 235 is equal to 17 into 13 plus 14. What does this statement mean? Primarily, we need to identify what all these stand for. 235 is the dividend, 17 is our divisor, 13 is the quotient and 14 is the remainder. Once we identify this, it is in the form of Euclid's lemma, isn't it, children? We will be able to write the statement. Very simple. We just write it as when dividend 235 is divided by the divisor 17, the quotient is 13 and remainder is 14. Children, can we write it the other way? Can we have the divisor as say 13 here and then you are given the remainder to be 14. So can we consider 13 as our divisor, children? No. Why? Because we have the condition that the remainder must always be less than the divisor. Isn't it, children? That is the condition. But here, if we consider the divisor as 13 and remainder as 14, what happens? 14 is greater than 13, which means the remainder is greater than the divisor, which is not possible. So the only possible way of writing is when dividend 235 is divided by the divisor 17, the quotient is 13 and the remainder is 14. And we know that given numbers A and B, Q and R are unique. So this is the only way of writing it, children. In case you have written the other way, please understand what is the correct way of writing and correct it yourself, children. Is it clear? Shall we proceed further? Okay. So next we had this question. Express in mathematical statement. A number A when divided by 8 gives a quotient Q and leaves a remainder 6. Here we are given what is the dividend. The dividend is given to be A and the divisor is 8. Quotient is Q and remainder is 6. We need to use Euclid's lemma and just write the statement. It says A is equal to 8Q plus 6. That's it, children. Okay. Shall we proceed further? Find the HCF of the following using Euclid's division lemma. So, the first set of numbers were 16,908 and 315. So, we express the bigger number in terms of the smaller one. Hence, we have 16,908 is equal to 315 into 53 plus 213. Here, mentally, if we have to do, we have to consider 315 as approximately equal to 300. 300 into 5 is 1500 and here you are given 1600 in the beginning. Isn't it, children? So that is how we mentally calculate it and proceed further. So next step, what happens? Our 315 becomes our dividend and 213, the remainder, becomes the divisor. So we have 315 equal to 213 into 1 plus 102. 315 can be divided by 213 only once. Okay, children. Next, what is the next step? Again, our divisor becomes the dividend and the remainder becomes the divisor. Accordingly, we have 213 equal to 102 into 2 plus 9. Does it stop here? No. We need to continue until our remainder becomes 0. So what is the next step? 102 becomes our dividend. And what is our divisor? 9. So we have 102 is equal to 9 into 11 plus 3. And proceeding further, 9 becomes the dividend and 3 becomes the divisor. So we have 9 equal to 3 into 3 plus 0. And finally we have the remainder as 0. So what is our HCF? The last divisor is the HCF, which is nothing but 3. So HCF is 3. I hope all of you have got this right, children. The next problem, 24,756 and 724. So we can express the bigger number in terms of the smaller number. So we have 24,756 is equal to 724 into 34 plus 140. Again here we have approximately 700. 700 into 3 is 2,100. Okay. Here the last 4 digit is 2,400. So 2,400 minus 2,100 is just 300. So we can proceed with this. That is how we mentally try to find the quotients, children. And now what happens? 1724 becomes the dividend and 140 becomes the divisor. So we have 724 equal to 140 into 5 plus 24. Next step, which is the dividend? 140 and divisor 24. So we have 140 equals 24 into 5 plus 20. And again 24 is the dividend and divisor is 20. So we have 24 equals 20 into 1 plus 4. And finally 20 becomes our dividend and 4 is the divisor. So we have 20 equals 4 into 5 plus 0. Hence the last divisor is the HCF. So what is our HCF now, children? 4. Okay. I'm sure all of you have got this right. Okay, children. So we use this Euclid's division lemma to understand a few more concepts in today's class, children. Let us take a quick recap about a little more about Euclid's lemma. So let us now use Euclid's division lemma and write the possible mathematical statement for the following. For example, suppose you are given the statement, children, a positive integer a is divided by 2. Then how do we write all the possible mathematical statement is what we are going to understand. This is required for your further problems, children. How you are going to read this statement, such statements, and convert them into mathematical form. Here we know that a is the dividend and 2 is the divisor. So what are the remainders, possible remainders? Yes, we know that the possible remainders are 0 and 1. That means you can have either 0 or 1 as the remainder. So with this, how do we write the mathematical statement? A is equal to 2q plus 0 and a equal to 2q plus 1. So if you read anywhere a positive integer a is divided by 2, immediately you must be able to write these two statements, children. Is it clear? Now suppose you are given a positive integer a is divided by 6. Then how do you analyze this statement and what are the mathematical statements that you should immediately write? That is what we are discussing. We have already learnt about Euclid's lemma and all the methods of writing the statement. But now here, suppose you read such statement, immediately what are the things that should occur in your mind and what is the mathematical statement that you should write? Because we use this concept for our further problems, children. Okay. So suppose you read this. A positive integer a is divided by 6. Immediately you should know that a is the dividend and 6 is the divisor. So when 6 is the divisor, what are the possible remainders? 0, 1, 2, 3, 4 and 5. So in that case we can write a is equal to the divisor is 6, isn't it? So we should be able to write this as a is equal to 6q plus 0, a equal to 6q plus 1, a equal to 6q plus 2, a equal to 6q plus 3, a equal to 6q plus 4 and a equal to 6q plus 5. So these are the possible statement. So as soon as you read such statement, these mathematical statement must immediately occur into your mind, children. That is why I have given you this exercise here. We will be using this in the forthcoming exercises. So let us do a few problems now, children. Here we have got a positive integer. We have to show that any positive even integer. We are studying Euclid's lemma about positive integer. Okay. So if it is an even integer, it is of the form 2q, and all positive odd integers will be of the form 2q plus 1. This is what we have to establish, children. We asked to show that every positive even integer is of the form 2q, and every positive odd integer is of the form 2q plus 1, where q is some integer. Okay. So let us proceed. Let us consider the integer to be a. Let a be any positive integer and q be the quotient. So what is the divisor here? Divisor is 2, because we are going to divide it by 2. We are going to consider the form of the equation to be 2q or 2q plus 1. That means indirectly we are going to divide the given number a by 2. So 2 becomes the divisor. And what are the possible reminders? 0 and 1 are the possible reminders. So what can we write the number a as? A can be written as a equal to 2q or a equal to 2q plus 1. When you consider this a equal to 2q, what does this mean, children? It means that this number a is divisible by 2. Isn't it, children? 2q means was 2 into q. Already we have seen. Suppose we have got any number 6 is equal to 2 into 3. It simply means that 6 is divisible by both 2 and 3. Accordingly, any number a is equal to 2 into q means this number is divisible by 2. And all numbers that are divisible by 2 are all even numbers. That is the characteristic of even numbers. Isn't it, children? So a equal to 2q must be an even number. And when you consider a equal to 2q plus 1, what does this mean? It is the consecutive to the even number. It is the next digit or the next number, isn't it? So they are all called as consecutive numbers. So any consecutive number of an even number must be odd, isn't it? So a equal to 2q implies the number is even, and a equal to 2q plus 1 implies the number is odd, since it is consecutive of an even number. Consecutive of an even number is an odd number. Okay, children. So this is a very important conclusion that we have arrived, and you must bear in mind. All positive even numbers are of the form 2q, and all positive odd integers are of the form 2q plus 1. So with this as the base, we try to solve a few more problems. Okay, children. Just to take a quick look about how you have understood about writing the literal statement in the mathematics. Let us now consider another number a, which is divisible by 3. Let us write all the possible forms in which a can be expressed. We know a is the dividend. So a is a positive integer and it is the dividend. And which is the divisor? 3 is the divisor. And q be the quotient. And what are the possible reminders? 0, 1, 2. So how can we express a in terms of all these parameters? Yes, we can write it as a is equal to 3q, a equal to 3q plus 1, and a equal to 3q plus 2. So having understood this, let us proceed further to understand a few more problems and logically analyze, children. A number a is divisible by 4. Write all possible forms in which a can be expressed and discuss if they are even or odd. First, let us write all the possible forms in which we can write the number a when it is divided by 4. We have already understood that. Let a be any integer and the divisor here is 4. So q is the quotient, and what are the possible reminders? 0, 1, 2 and 3. So how can we write this number a in terms of the divisor, quotient and remainder using Euclid's lemma? A is equal to 4q, A equal to 4q plus 1, A equal to 4q plus 2 and A equal to 4q plus 3. Now let us consider A equal to 4q. Just now we have derived an important conclusion that all even positive numbers can be expressed in the form A equal to 2 into q. So let us see if we can express this A equal to 4q as in the form of A equal to 2 into something. Okay children. So I can write this 4q as 2 into 2q. Is it clear children? So I have written A is equal to 2 into 2q. This 2q is nothing but some other number, isn't it? It could be 2 into 3, 2 into 4, something, isn't it? So we write this 2q as some other q1, simply to say that it denotes some quotient. That's all. 2 into some other quotient it denotes. So we can write this as A is equal to 2 into q1. That means we have expressed A equal to 4q as A equal to 2q1, which means that this must be a even number. Just now we have understood that. So this implies that A equal to 4q is an even number. Is it clear children? The next one that we have is A equal to 4q plus 1. We have to discuss whether this is even or odd. What is this? This must be odd. Why? Because it is consecutive to an even number. Okay. So consider A equal to 4q plus 1. This is a consecutive to 4q. So this must be an odd number. Let us consider A equal to 4q plus 2. Okay, this A equal to 4q plus 2 can be written as A equal to 4q plus 1 plus 1 plus 1 plus 1 children. Okay, so it is written like this. So in that case what happens? This is just 4q plus 1 plus 1. That 4q plus 1 is an odd number. To an odd number we are adding 1. That means it is consecutive to an odd number. So this A equal to 4q plus 1 is consecutive to an odd number. Hence it must be an even number. So A equal 4q plus 2 must always be an even number. And what about A equal to 4q plus 3? It must be odd because it is consecutive again to a even number. So this is how we have discussed whether when any number divisible by 4, the different forms are A equal to 4q, A equal to 4q plus 1, A equal to 4q plus 2 and A equal to 4q plus 3, and among them A equal to 4q and A equal to 4q plus 2. The alternate numbers are even 4q plus 1 and 4q plus 3 are all odd. So we continue further and we solve one more problem which is likely to be important for you children. Okay, so that any positive integer is of the form 6q plus 1, 6q plus 3 or 6q plus 5. Okay, all odd integers are of this form, he is saying. That means we should consider any number A and it is divisible by 6. Okay children, consider the number to be divisible by 6 because we have got here 6q, 6q and 6q. Okay, so any number A, quotient is q and the divisor is 6. So what are the possible ways? Let A be an integer, q be the quotient and 6 be the divisor. What are the possible remainders? Possible remainders are 0, 1, 2, 3, 4 and 5. Okay, so let us write down all the mathematical expressions with this parameter. Hence we have A equal to 6q, 6q plus 1, 6q plus 2, 6q plus 3, 6q plus 4 and 6q plus 5. These are the possible ways of expressing A in terms of the dividend 6q quotient and the remainders 0, 1, 2, 3, 4 and 5. Now we have to say among these the odd integers are 6q plus 1, 6q plus 3 and 6q plus 5, for which we consider A equal to 6q plus A equal to 6q first. So as usual, we'll try to express the 6q in the form of 2 into something. So we can write this as 2 into 3q, and 3q we denote it as some q1. So we have expressed this as 2q1. So a equal to 6q has been expressed as a equal to 2q1, and any number, if you are able to express it in the form of 2 into something, must be always a even number. So implies a equal to 6q is an even number. So when a equal to 6q is an even number, all other numbers a equal to 6q plus 2 and a equal to 6q plus 4 are all even. They alternate ones. Okay. Then what happens to the consecutive number of a equal to 6q plus 1? The consecutive to a equal to 6q is a equal to 6q plus 1. So a equal to 6q is even. So a equal to 6q plus 1 must be odd. And a equal to 6q plus 3 also must be odd. So hence a equal to 6q plus 1 and a equal to 6q plus 3 and a equal to 6q plus 5 must be odd numbers. Is this clear, children? So we have tried to understand so far how to express any statement in the mathematical form. That is, when in the statement, when any dividend, divisor, quotient and reminders are given, we know how to express them into the mathematical form and discuss whether the given number can be even or odd. Okay, children, the main condition is if you are able to express any number in the form a equal to 2q, then they are all even numbers, and if you are able to express them in the form a equal to 2q plus 1, they are all odd numbers. Clear, children? Fine. There is another way of analyzing the same, children. We have understood that if you are able to express any given number in the form of a equal to 2q plus 1, then it must be odd. Okay. So let us see if we are able to express these numbers. That is a equal to 6q plus 1, a equal to 6q plus 3 and a equal to 6q plus 5 in the form a equal to 2q plus 1. And then we can infer that they are odd. So consider this a equal to 6q plus 1. This can be written as 2 into 3q plus 1. And this 3q is another number, isn't it? So this is 2 into some other number plus 1. So this 3q, I replace it by another number, or this another quotient as 2 into q1. So I write this as equal to 2 into q1 plus 1. That means I have expressed this a equal to 6q plus 1 in the form of 2q1 plus 1, or simply 2q plus 1. 2 into some quotient plus 1. Okay. Now let us consider the other form a equal to 6q plus 3. If I am able to express this also in the form 2 into some quotient plus 1, then this is odd. So this is equal to 2 into 3q, and this 3 I am writing it as 2 plus 1. Okay, children, this 3 is being written as 2 plus 1. Why? Simply we want plus 1. So this 3 can be written as 2 plus 1. So this is written as 2 into 3q plus 2 plus 1. So let us simplify this. This becomes 2 into 2 will be the common factor for the first two terms. Okay, children, for these two terms, the 2 is the common factor. Yeah, between these two terms, 2 is a common factor. Hence, I have written that as 2 into 3q plus 1 plus 1. So again, this is 2 into some quotient plus 1. We indicate this as 2 into 3q plus 1 as 2 into q2 plus 1. 2 into some quotient plus 1. Similarly, let us consider a equal to 6q plus 5. We can write this as 2 into 3q plus 4 plus 1. Why we have written plus 4 plus 1? Because we want to have plus 1. Something plus 1. 2 into something plus 1. Hence we have written this 5 as 4 plus 1. Okay, children. So on further simplifying this, we have this as 2 into 3q plus 2. Taking 2 as a common factor, between the first two terms. Okay, so again this is 2 into some quotient plus 1, and I write this as 2 into Q3 plus 1. So we have been able to express A equal to 6Q plus 1, A equal to 6Q plus 3, and A equal to 6Q plus 5 as 2 into some quotient plus 1, which indicates that all these are odd numbers, since that is the condition for any integer a to be an odd number. If any integer a can be expressed in the form 2 into quotient plus 1, then it is an odd number. Here we have expressed all the forms of a as 2 into some quotient plus 1, and hence they are all odd numbers. Now, we have got some problems here, children. A sweet seller has 420 kaju barfis and 130 badam barfis. Okay. She wants to stack them in such a way that each stack has the same number and they take up the least area of the tray. What is the number of that can be placed in each stack for this purpose? In the sense, she has got all these kaju barfi and badam barfi. She wants to stack them one above the other as it is shown here. Okay, she wants to stack them one above the other in such a way that each stack has the same number. Same number. Suppose you take this stack, this stack, this stack, this stack, all of them must have the same number. And the other condition is they take up the least area. That means what? They must not take up, see here, they have taken up so much of a space. Suppose I put the one upon the other like this. Okay, I stack them like this. What happens? Then they will have the least area, isn't it? So that means what? We are asked to find how many maximum numbers that can be there in each stack. And it should be common because we should have the same number. Each stack must have the same number, and what must be the maximum number that can fit in each stack. That is what we are asked to find. That means there must be some number x which divides both 420 and 130, which means that we need to find the HCF of 420 and 130. That is the meaning. So we know how to find the HCF, isn't it, children? The main thing that lies in these is you should understand what is asked and what you have to find. So you should know that all these we are trying to find a common divisor for both. That if you are able to get, then the rest is very simple, since you are already mastered how to find the HCF of any two numbers, isn't it, children? So find the HCF of 420 and 130, and you must use Euclid's lemma only to find the HCF. So we proceed like this, and then we find the HCF to be 10. So she can stock them 10 each. Okay, so here she will have 42 and she will have 13 of badam barfis. Okay, children, let us proceed further. We have another situation here, children. We have a problem which says that we have an army contingent of 616 members and they have to march behind an army band of 32 numbers in a parade. The two groups are to march in the same number of columns. What is the maximum of columns in which they can march? So let us understand this problem first, children. What does this problem say? There is a contingent of 616 members. Say this is the contingent which is consisting of 616 members. And we have an army band. And how many are there? 32 members. So what the problem says is this army, that is contingent, they must march behind this band. Okay. And all of them must be placed in equal number of columns. So we have the band in some certain number of columns. All of them, there is a group here, band, placed in certain number of columns. And this army has to follow them. And they also must have the same number of columns as this band. So that is our problem. So what should we do in order to solve this problem? We have to, this is how all of them should march together. That means we need to find a common divisor for both 616 and 32. That means we need to find the HCF of 616 and 32. This will make all of them move in the same number of columns. Okay, so they must be divided. Both the contingent and the band must be divided into equal number of columns. We have to find a common divisor for both of these. That means we have to find the HCF. So we know how to find the HCF of these two numbers using Euclid's lemma. So we go about 616 is equal to 32 into 19 plus 8, 32 equal to 8 into 4 plus 0. So hence the HCF is 8. So they can be made to stand in 8 columns. Okay children, both the band and the army contingent can be made to stand in 8 columns. So we have worked out a few problems, and let us see what we have learned in today's class, children. We have learned, given a number A and a divisor B, to write all forms of A. And then we have seen what is the condition for any number to be even or odd, and to analyze if a given number is A with a divisor B is even or odd. These are the things that we have learned. Please watch this video as many times as possible so that you understand it clearly, and if you have any doubts, please put them into the comment box and I will reply to you as soon as possible. As usual, I have an assignment for you children. Please take down this problem and work it out. We will discuss in the next video. Thank you for watching. See you soon.